Hey, what is going on YouTube? All right, so some good news, exciting news, at least from my perspective. I have finished Advent of Code 2024 all the way through. Uh, Got kind of busy over the Christmas holiday, so I did not live stream, but I am complete. And so I wanted to give a brief recap. I know I ended on day 21 with an incomplete solution, so I wanted to cover that and then kind of go back. I think day 20 I skipped and a few other days. So let's start with day 21. With day 21, we started out with having a numpad that needed some sort of directional movement, but it wasn't just as simple as the directional movement. We couldn't actually press the key presses ourselves. We had to use a num directional pad to press the keypads on the numpad by moving essentially a pointer to the different location and then activating it. And then it got worse because we didn't just have one of those, we had two of those in addition. So we were moving a pointer and an arrow key on a layer that was controlling a numpad that then was being controlled by, it's a numpad that was being controlled by an arrow set of keys and an activation key that was being controlled by an arrow key, an activation key that was being controlled by an arrow key and an activation key. And so in part one, my approach was pretty brute force. It was just let's generate all of the sequences, and honestly kind of fell in line with what the initial input result was showing of these long strings of data indicating what the best possible solution was and generating that data. So I kind of stuck in that pattern for part one. And honestly, while that wasn't the solution for part two, it gave me the framework for troubleshooting and better resolving part two. So part one was kind of a wash when we got to part two, but that's how I approached it. I created this sequences or sequence method. This sequence method took a given set of inputs, created a Cartesian product from it, and then did a breadth first search across the board, and then came back with all the possible outputs and provided that. That was kind of step one. That got done. But for two, for a length of two, that was not too bad. But when you started getting to three, four, five, and six, that was not going to work anymore. So that's all part one. Part two, slightly way more complex. It's pretty much the exact same problem, but instead you get down to 25 robots that are layered on top of this numpad. And so you could estimate that while we had a pretty reasonable amount of string length here in part one, in part two that got to some unreasonable size scale. So how do we solve this? Well, the way we can approach this initially was like, well, I'll just see how long it'll take to run, and we'll run it now. um, this is with the optimized version. Obviously once it got past layer 3, it took incredibly a long amount of time, to a point where it was never going to finish anything reasonable. So we had to reapproach the problem. So instead of building the entire sequence, of 029A, what we can actually do is, where's my iPad at? Can you grab my iPad for me? I'll grab my iPad here and we'll do some drawing. But instead of 029A, we can generate the characters for a single sequent part. So I can generate the characters for just the zero and look at that entire tree 25 layers down. And then while I do that, I can cache each individual layer. So it's essentially the approach. Instead of calculating the entire string for 029A all at once, all the way down 25 layers, instead we can focus on just a single character, and then when we end up with repeats, we can cache those layers. And by using this caching mechanism for calculating the sequence parts, we end up with a much faster solve. So I'll draw that out here in a second because I think it's beneficial to look at from a drawing perspective. So let's scroll down here. We'll do blue, and we'll scroll down here. So what I did, the initial approach, 029A, took this entire sequence and would attempt to generate level 1, which was some sequence of numbers and letters, which expanded down here. And then it would pipe that into the next sequence function, layer 2, which would be even more. And then that wasn't so bad, but now when we got to level 3, it was getting exponentially worse and essentially filling up memory space and becoming out of control. So this did not solve part 2. So I abandoned that solution, and instead the answer is, if we take each character at a time, everything starts at the A position. So technically, even though this is 029A, it's technically A029A. And instead, what we could do is calculate on layer 1 the moves that it takes to get 2 from A to 0, and we can take just those, which are left and A, I think it is, or whatever it is. So we look at the numpad up here. That is just what is highlighted in yellow here, the left and the A. So understanding that, we can come back down here and we could say, okay, now that we've generated on the first layer the move left in A, on layer 2, we would just take the first character here and we would generate what it takes to press that in layer 2. Then we take the first character and see what it takes to produce that in layer 3, so on and so forth. And so what that means then is, if we zoom this out a little bit, instead of producing something that required us to produce each layer in its entirety all the way down these layers, we are instead only focusing on one side of the tree at a time. The great thing about this is that we can also cache this value, and this is how we get through day 21 in a very efficient way. We cache the character to character. So in this case, if it's layer 1 or level 1 or depth of 1, it would be depth of 1. So we would, and then it would be this to this. So we would have something in our cache that looked like, I think we did something like, scroll down here just a little bit. And we'll go back to this. So our cache looks something like, and that 1 is considering the depth, and then we would equal that to whatever the count is at that layer. And so what this allowed us to do, actually I think this depth would be the inverse of this. I think this starts at 25 and goes down to 1, but either way, we would cache whatever that value was, so that any time at level 25, if we saw this pattern, we already knew what the count is. And so this allows us to solve day 21 really fast. Let's take a look at what the code looks like for part 2. So we'll ignore part 1 because that's pretty slow, and we'll look at part 2, which is where the meat of our speed is. So part 2, we use some of the technique from part 1. We get the sequence of the numpad. So that's going to be our, 029A. It's going to be what characters need to be pressed and what sequence, based on the layer 1. Then we take those sequences, and instead of, we do have this upper level method called compute key press, but instead of computing every single key all at once, we're just computing a specific key press. And so that'll be from A to, well, if we do something like, that'll be from A, or A, if we were looking at the first layer of 0, it's technically this, right? We start at A, then we're pushing the left and then we're pushing A, which gets us to 0 on the numpad. And so each computation of key press takes us from that first character to the next character, and then the next one would be from this character to that character, etc. And we can compute that entire tree, and then we cache that result here, so that if when we hit compute key press, if it's in that cache, we just return it. This is what gets us this really fast execution time where I can execute part 2 in less than a second. So if we get down to a depth of 0, we know that it's just the position from character to character, so that's going to be 2. Although this is kind of redundant, I put it there for testing. If it's a depth of 1, we obviously need to return whatever those values are. And then otherwise, we just sequence and we recursively call compute key press. And that gets us our final result. That's how we got through part 2 here. This is in my GitLab repo. I will say, as you join and as you're watching this, if at any point you're stuck on any particular problem at all in Advent Code 2024, let me know. We could dive into those specifics. I'm just reviewing the last couple of days, catching everybody up onto where I'm at, but I'd be more than willing to help out, give some suggestions, etc. So that's day 21. That's where I got stuck previously, and I'm quite pleased to say I got through this one. It took me a little bit to think through it, to understand what I had going on, but once I was able to get some free time around the holidays and really dig in, I was able to get it knocked out. Right. So let's look at day 22. If my internet connection isn't terrible. While that's loading, we'll bring up day 22. Now, day 22, I'm not super happy with. I don't know why this is not working for me right now. So day 22, pretty straightforward. We ended up with some sort of number generator that generated some scale of numbers. That's kind of part 1. And then that data and input was used in part 2. Same kind of functionality, but then we had to analyze the data output. And then from that data output, make a decision on certain pattern matches between the different sets of inputs. The way that I approached it was just generating those numbers and then sliding through, looking for what might be the best possible match, what's the best possible projection, and then looking through all of those projections and determining which one was the highest value of the projections. Not really great, not a great solution, but it is something that completes in under 5 minutes. And so I was happy enough with that. Something I'll probably come back and revisit. But if I can get this to load here, we can dive into it a little bit more. So we have to calculate these string of numbers, figure out their secret number, choosing the price. So it's important to be able to predict the sequence of search numbers for each. So we did all that. So I calculated all these numbers, and then from there we would determine what the sum of the 200 secret number was. That was pretty straightforward. And then part 2 was sliding through. So in part 2, it was just simply taking those numbers in the list that we generated and sliding through them. And we would do that based on basically just a sliding window from the 0th number to the 4th number, and then or 3rd index. So 4 numbers total. And then I would just slide those forward step by step, looking at the different prices. And then if we were to match on that first price for a given projection or sequence, we would return that score, and then we would determine whether or not that was the highest, and we would do that. As you can see, part 1 is pretty fast, part 2 is pretty slow. I think there's a more efficient approach that we can take here, and that's something I want to look at a different time. But at this point I did get through all of 2022, or sorry, Admin Code 2024. So I think I'm okay with this for now, but this is something I want to revisit. Right. So day 23, this one was pretty interesting. So this one, we actually were able to build some nodes, and I like a good node problem like anybody. Yeah, so there's part 2 of day 22. Let's run part day 23 here. Let's see what our output is. And so let's talk about this problem real quick. Let's re-review. We end up with this list of networks, and we end up with connections that are bidirectional. They're not a specific direction. We have this list of connections between more than one individual. And what we're trying to do is isolate computers that are connected to each other. So in the first part, we needed to find anything that were in sets of 3 that included somebody with, I think that started with a T, if I'm not mistaken. Let's see here if we go down to the problem. How many contain at least one computer with the name that starts with T? So the way we accomplish this is by building everything into nodes, and then each node had a name, and then each node had a set of neighbors, which was a map of the names to the given nodes. And what I would do essentially is I would go through and all of the things, and I would essentially check to see if the node existed. If it didn't, I would create it, and then I would create the other node, and then I would associate each node with the other node. So I'd make sure that that node existed. So if it hadn't been created and it was in either side, we would create it, and then I would see, did it exist? And then finally, pretty straightforward, I would check to see if it had the prefix of T, meaning that it started with T. And if we had a node that did not start with T, we would continue. Otherwise, we would take that, and then we would look to see, does it in fact have at least 3 neighbors where the name was not the name of the current, and it was associated back to the N1 name. And if that was the case, then we had a network of at least 3, and we were good to go. So that was pretty straightforward. As you can see, that didn't take very much time to calculate. And then the second part was a little bit more complex. So out of this network, there was too many results. We're still looking for the LAN party, and we had to look at it a different way. We'd have to see what would be the largest set of computers that are all connected to each other. And so if we look at the above example, we get this list. But essentially, if we have KA, who is connected to CO, which DE is connected to CO. We also have KA, which is connected to DE. This is code kata, or code kata. So we had to determine which computers were all interconnected. And so the way that we did that was by looking through, we build our set of neighbors, and then we build this network, and we find all the computers that are interrelated. And so the way we would do this is we would take a node, and then we would add that to a map, and then we would look at the entire network, and we would try to see where the same node was seen on another node. We would use this find method here. So anytime that we would have a neighbor, we would check to see if that neighbor existed in our match list. And if it didn't have all the neighbors, we would continue. Otherwise, we would consider it. We would copy the neighbors, and we would kind of create this coalesced list until we came down to just the list of nodes where our neighbors overlapped in the greatest context. So that would, if we had node A with a list of neighbors and node B with a list of neighbors, and they both had a subset of neighbors that overlapped, that would indicate that they were in network some way with each other. And then we would check those other neighbors to see if they also overlapped with each other to see what that largest set of overlapping neighbors was. And that's how we solved part 2 of day 23. Moving on to day 24. We'll we'll run day 24 here. Day 24 is done. So day 24 was interesting to me. It threw me for a loop at first. I didn't understand, but then I realized that really we were just dealing with binary math or binary arithmetic. The part that threw me off in part 2 was the fact that it gave an example of an AND gate. However, the actual problem was addition. So we'll get to that in a second. So pretty straightforward. We had a set of gates, and we had inputs, which are X gates. Each of these inputs represent a position in a binary number, the most significant bit being the 0, 2, and the least significant bit being 0, 0, I believe, in reverse order, if I have that correct. And we would have something like this. So X00 0 and operator Y00 0 is the value of Z00 0. All of the Z gates are your outputs. So I wrote something that would iterate through these, build all the gates, walk through the gates, then come up with our total. And we received an output of this value in decimal. And that was essentially our result. So that went well. I do have kind of a representation of day 24 here. If we want to look at a specific example, let's see here. I'm all over the place with my notes, but I think if I can do something that's somewhat readable here, this is somewhat helpful. Maybe not. So the point is, this is just binary arithmetic is really what it is at its core. And so with these gates, they give you a value by walking through the process of adding them up in part 1. And we could see that here with the get Z outputs. However, the data that you receive from that is not accurate. So you have to figure out which gates are incorrect. So the approach that I came up with after tinkering with this for a few is that we know that Z00 here is always going to be an XOR from X00 and Y00. Okay, Z01, which is the next bit, not the least significant, but the next least significant bit, is going to be an XOR of a value, MGK in this case, that is an AND, not an XOR, an AND of Y00 and X00. And we can derive the right side if that's not true. So every Z00 value must be a part of a gate that is XORed in, and the XOR has to be not in the case of 000 or Z045 actually on the backside, but it has to be a derivative of one of the XORs must come from Y00 and X00. So what I did was I said, okay, well, if we start at Z00 and understand that as the least significant bit, we can then progress to Z01. We can then progress to Z01, and when we're at Z01, we can look back at Z00 and look and see what the inputs are for its gates. So that doesn't make so much sense for Z01 to Z00, but on Z02, you can see that if we look back at what creates Z01, we can see that it should be RKF and MGK. And so this should tell us that we can get here from RKF and MGK, or an XOR directly on X02, X01. So that was really the secret sauce, is just understanding what our validators were. So if we look here, I created a method called fix gates, and I actually put all this in a separate file because there was just so much code that I ran through and helper functions for the gates. But if we call gates.fix, we really just have a couple of validators here. So what are the validators? Yo, what's going on, someone? We're just going through Advent of Code 2024, a recap of where I was at. So if there's something specific or a question that you have, please feel free to ask. I, at this point, solved all the problems, so I have a pretty clear understanding, at least mostly, on all of them. So here's what the fix looks like. If we're on Z00, we need our A and B gates to be X00 and Y00, and we need it to be an XOR. If that's not true, then we can find the gate by the sources where it's an X00 and Y00, and it's an XOR, and then we know we can swap those two gates. That means Z00 is wrong. That actually wasn't a case for me, but I kind of saw it as a potential problem, so I said, okay, let's talk about that. Z45, because there are 45 total output possibilities with a carry bit. So Z45 is the 46th option, and that is only if our addition gets us high enough. So this is here just kind of as a failsafe. I didn't really do anything with the swap here. If you have Z45 as your problem, then you probably need to address it. But this was not a problem for me, so I ignored it. So since we're going through, this fix is particularly on Z gates. So we loop through all the Z gates and we're validating, is Z00 good? Is Z45 good? As long as we know Z00 is good to go, that means we can check Z01, Z02, Z03, Z04, Z05, etc. And what we're actually doing is fixing the gates as we go. So we're swapping them as we go, and we're reporting back the swap that is taking place. So what are we doing here? We check to make sure, since we're a Z gate, that our operator is always an XOR. So if we go back to our diagram down here, if we look at this here, you'll notice a pattern. This here, and this here, and this here, and this here. Every Z gate is XORed from a derivative of X and Y input XORed, and some derivative of X and Y, and the previous derivative of X and Y. And that's how it does the carry bit function. So this is just pretty standard binary math. Once I realized that, which did take me some time, then you can go through here and say, okay, if it's not XOR, find the gate by the source, which should be whatever the original gate is, the OG gate, which would be my gate name. So if I'm on Z004 or Z04, I want X04 and I want Y04 and I want the operator to be an XOR. Find that gate and then find the gate source where it's an XOR, and then swap those gates. So I know that my gate is not set up correctly. So we can swap that here. So that was the swap here. Then if that's not the case, if we can't find our source XOR gate, that means that the Z gate is pointed incorrectly. So instead, let's look at the previous Z gates and operator, understand what that was, then find the OR operator, then find its associated XOR, and essentially this last case is building the tree up from the lowest possible position up to the next possible position up to what it should be, because what effectively is happening is this gate might be wrong or this gate might be wrong. We know that the inputs to the gate are never the problem. It's always the destination that is swapped. And so when we do that, that allows us to walk that gate structure back up and essentially derive what the correct gates should be and then to swap them accordingly. And so in my output here, you can see this was my answer. I had 3 Z gates and 5 non-Z gates that were flipped, and this correctly allowed us to walk through and correct all of those gates. If anybody has any specific questions or is stuck in any part, please let me know. I'd be happy to walk through those in more detail. Right. So that was day 24, and that's how we approached that one. That one took me a little bit longer than I'd care to admit, but we've got that one solved. And then finally, day 25. This one was super easy. Kind of refreshing to be super easy, but I guess maybe that's the strategy with the last day of Avenue Code. There's only one part, and we end up with input that looks like this. And the things that start on the top are locks, and those that have hashes on the top are locks. Those that have hashes that start on the bottom are keys. And so the way I chose to approach it was probably a bit overkill, but I created a key struct with a heights method and a lock struct with a heights method. And this allowed me to iterate through each one and build the keys and locks. So whether or not the first row had a hash, that would consider it a lock. Otherwise it was a key. And then we could simply get all of our locks, get all of our keys, and see what locks heights fit the key heights. And so if we look at the fit, we basically are just comparing the two values. And if we're greater than 5, we return false, meaning that there's an overlap. Otherwise, we return true. And that's pretty much it. That one was not super complicated. And then once that's done, part 2 is simply deliver the chronicle again. Delivering the chronicle. And that's how we accomplished or finished up our Advent of Code 2024. It's a nice little graphic here. Nice little design. I like the ASCII, not ASCII art approach. Got some fireworks, stars, Santa's sleigh back here. It's pretty exciting stuff. So that's pretty much it. I think, at this point, I like to also say that I try to build tests for all of this. So if we just run all of 2024, we can see that all of those tests pass, at least to the ones that had tests. Great place to be. I think it was day 24 really tripped me up with the AND gate. I don't have actually a good test passing for part 2, so that's not included here. But we did get through that quite painfully so, but did end up completing it. So I would say this, I'm very excited to be through Advent of Code 2024. I realize that some of you helped me through that process. There were different times and different situations where someone really stuck it out with me and kind of helped work through a problem or helped walk me through something that was a bit complex, but it was worth it. Each day of this year, I learned something new or grew something or became more capable in a different area. And it expanded my ability and strengthened me as a software engineer. And so I would say, if you haven't taken the time to finish Advent of Code, don't give up. Keep pushing forward. Keep working on it. Get it knocked out. Don't give up. And allow it to grow you. If you're stuck on something, like I was once or twice, it's because I was taking the wrong perspective on it. And all Advent of Code is going to do is help you grow as a developer, help strengthen your ability, and help you move on to your next advancement, I guess, in your career or your ability. So that's all I have. That's all I have for tonight. I'm excited. Advent of Code 2024 is complete in full. I may go back and do some other other videos here, but it's quite an accomplishment for me, and I'm excited about that. So I'll be making more content, not admin code related, I don't think. Maybe some admin code related stuff here and there, but I'll be excited to continue to do some more stuff here moving forward. Until next time, thanks for joining.